8-7, extending tables. So today we're going to talk about extending or almost creating our own tables based on information, like the tables we've been working on in the last few days. So we need a couple of words. So the first definition is sequence. A sequence is a set of numbers that follows a pattern, for example, 2, 4, 6, and 8. Okay, and the second term is corresponding terms. It means terms that match one another in a sequence. So I'm going to give you notes on how to find corresponding terms and how they relate. First step will be to use each rule that you are given to make a table. The starting value for each rule is the first term. Second, you will then look for a way that the values in each column are related, just like we did with addition and subtraction and multiplication and division. You determine how they related to one another, those numbers, in order to figure out if it's plus, minus, multiplication or division, and then by what amount. And I'm going to show an example of that now. So when we do these problems, what we're going to see first is a blank table. So I want you to go ahead and copy that. And you'll notice that I have across the top first term, second term, third term, and along the side here, rule A, rule B. So we can't fill this in unless we're given information. The information we're going to be given is that rule A, we're going to start with 1 and then add 1. And rule B, we're going to start with 2 and add 2. So when it says start with 1, it means the first term. So for rule A, let's just do that first. Start with 1. So the first term is 1. And then we add 1 as we go along. So 1 plus 1 is 2, and 2 plus 1 is 3. So for rule A, my first term is 1, my second term is 2, and my third term is 3. Rule B, it says to start with 2. So I'm going to start with 2 and then add 2. So 2 plus 2 more is 4, and 4 plus 2 is 6. So to review, we used each rule to make a table, and we knew that the starting value for each rule is the first term. So we figured out our table. Now we have to do the second thing, which is look for a way that the values in each column are related. So first I want to point out that in the beginning we took notes on a definition called corresponding terms. So here's where you see that. These are corresponding terms. 1 and 2 are corresponding. 2 and 4 are corresponding. 3 and 6 are corresponding. So these are the terms that line up with one another because these are both third terms, second terms, and first terms. So I'll just use an example there. 3 and 6 are corresponding terms. Make sure you can see that. Okay, so now we have to find ways that each column is related to one another, and the way we answer it is not like the rules that we did previously. It's more stated in sentences, and we'll use the terms rule A and rule B to do some comparisons. So if I look at 1 and 2, and 2 and 4, and 3 and 6, I know that in order to get to 2, I could add 1, or I could multiply 2. And we want to see what the consistency is, so those are my choices. But if I go over here to the 2, if I add 1, I get 3. So that I know that it's not adding 1. But look at, if I multiply times 2, 2 times 2 equals 4, and 3 times 2 equals 6. So I can write a statement with regard to how these values are related like this. Rule A numbers relate to rule B numbers because rule B, numbers are 2 times the corresponding rule A number. Sounds crazy, I know. You could say it like this. Rule A times 2 equals rule B. You could also say rule B grows 2 times faster than rule A.